Welcome back, and today we're going to be solving threesome, the Leetcode medium problem. So this one is important, I believe, because it shows how we can take the two-pointer idea from twosome 2 and carefully extend it to handle three numbers instead of two. So let's understand the problem first before we dive into it. So we're given an array of integers, and we need to find all unique triplets that add up to 0. So that means we need three different indices, and the sum of those values are exactly 0. And no duplicate triplets are allowed in the output. So all of them have to be unique. So as you can see right here in the problem, right here, nums at I, nums at j, nums at k, they all have to sum up to 0. So immediately the straightforward approach is to try every possible triplet. So 3 nested loops, and that would be O of n cubed. That's way too slow for us for large inputs. That's way too slow. So we need a smarter way to do this. So the key idea here to solve this problem is to turn this threesome problem into a twosome problem. So instead of trying to pick three numbers at once, we choose one number first and then solve a two-number problem for the rest. So we have three numbers here in this problem. We need three numbers that add up to 0 triplet, right? So let's just call it A plus B plus C. These are our three numbers that are supposed to add up to 0. And we choose one number first. So let's say we just isolate A. So it'd be B plus C equals negative A. So if I already know what A is, then I don't need to guess all three numbers anymore. So I just need to find two numbers that add up to negative A here. So this is the bridge to twosome. So yeah, but before we do anything here, before we apply any two pointers, we need to sort first. So to efficiently find two numbers that sum to a target, we need obviously two pointers, but two pointers only works on sorted arrays. So the first thing we do is sort the array. So let's just use this example here, nums here at the example. So let's sort this. So this should become -4, -1, -1, and you got 0, and you got 1, and then you got 2. So this is now a sorted array. So now the structure becomes clear. So after sorting, we walk through the array from left to right. At each position, we treat that value as A. Everything to the right of A is now a sorted subarray. So on that subarray, then we would run that twosome 2 search. So this is not magic. It's like pretty structured. So obviously, let me just explain more what choosing A actually means. This is a really important part of the problem. So when I say choose A, I just mean I'm deciding that nums at I is the first number in the triplet. So once I do that, I never touch it again for this iteration, what we're iterating through. So let's say first iteration, I decide, this is A, -4 is A. So now I only search to the right of A. Why? Because the array is sorted, remember, and using elements to the left would cause duplicates, and we need distinct indices. So now we apply two pointers to the remaining part. So for our fixed A, we want, obviously, let's say we have a left pointer. So we would have a left pointer here and a right pointer here for the subarray. And we want the nums at the left pointer plus the nums at the right pointer to equal -A, remember? So we just place the left pointer after A, just after A, and the right pointer at the end of the array. So now this is exactly twosome 2. So at every point, so at every step, if the total sum is too small, then we would move the left pointer to the right. So let's say like if the sum of a plus the left pointer plus the right pointer, if it is like less than 0, then we would need to, so if the sum is less than 0, then we got to move it this way to get a bigger sum, right? And the same thing if the sum is too big, if it's bigger than 0, then we move the right pointer left to get a smaller sum. So if the sum is 0, if we get the sum t equals 0, that means it's a valid triplet. That's what we want. So it's no guessing, it's no brute force in the solution. So now let's talk about duplicates. So if a is the same as a previous value we used, then we'll generate the same triplets again. So we skip it. So we would need to write that logic into our code. I'll explain that later. So it ensures uniqueness. So we also need to skip. So after we find a triplet, we have to update our pointers, right? So how would we do that? So after finding a valid triplet, we move the left pointer forward, because if the next value is the same as before, it would generate the same triplet again. So we skip duplicates on the left pointer as well. So this prevents obviously repeated answers. So now that I've cleared up the logic, let's code it exactly this way. So let's go to the code here. So now we're returning an array, right? So array of arrays is what we're returning. So we'll store what we're returning here in results, an empty array. Store results and result. And we sort the array first. Remember, we have to sort the array before anything else, before we even think about applying 2 pointers. So we call the sort on the nums array. Okay, so now our array is sorted. So now we have to loop through the array and treat nums at I as the first value a. So how do we do that? So for I, and then we will have a, because a will switch every step. And okay, so now remember, we want to prevent duplicates first for a. So let's say if I is more than 0 and a is equal to nums at I minus 1, then just continue. We're going to skip that. So this is basically saying if a is the same as the previous value, then we skip it to avoid duplicates. So now that we've cleared that, now we can actually start the 2 pointer, the 2 sum. So now now let's define our pointers. So we have a left pointer, then we have a right pointer, and then obviously a left pointer will start right after a. So we'll do just I plus 1 simply. That's why we're doing I plus 1 instead of just like 0. And then our right pointer will just start at the end every time. And now we want now I will nested while loop here for the 2 pointer. So while left less than right. And now we compute the current sum. Remember, it's the same as 2 sum 2 if you remember. So now very similar. So now let's just call this 3 sum here. So now we compute the current sum. So do a plus nums at the left pointer plus nums at the right pointer. So now this is our current sum. So now we have to check if the sum is too small or large. So let's do the conditional. So if 3 sum, if the current total is less than 0, that means the sum is too small, and you move the left pointer right. So we increment the left pointer to get a bigger sum. And now else if, let's say, now what if the sum is too big, if it's more than 0? That means we need a smaller sum, and we would decrement the right pointer to get a smaller sum. Move the right pointer left. And now for the last case, if it reaches here, that means you found a triplet. So now we just append to our result the triplet. So append and an array, and it'll be just A, and then nums at the left pointer. Then we got nums at the right pointer. And there you go. This will append our triplet. So now we've done that. Remember, we also now at the end here we have to update our pointer now that we've got a valid triplet. So now that is where we would just move the left pointer forward and skip duplicates so the result stays unique here. So we do that with the while loop. So while left less than right and nums at the left pointer is equal to nums left pointer -1, then increment. So this will help us prevent duplicates and results stay unique. So now that we've done that, we can simply just, if I haven't done anything wrong, I hope, we can simply just return result, and we can test it here. Oh my god, what am I doing? So that makes sense. Okay, all the test cases passed. That's good. Let's submit it. Yep. And there you go.